Welcome to today's video on infrastructure planning. My name is Margot Wijnen and I'm a professor of Process and Energy Systems Engineering at Delft University of Technology. Why is the subject of infrastructure planning so important and what makes it so challenging? Infrastructure is capital intensive, which implies a long economic lifetime, typically decades. The technical lifespan is even longer than decades if infrastructure is well maintained. In the Western world, most infrastructure development dates back more than a century. In many established infrastructure networks, whether electricity networks, road and railway networks, or drinking water networks, components may still be found that are more than 50 years old. Take, for example, the use of lead piping for drinking water distribution, which was the standard 80 years ago. We now know that lead in drinking water is detrimental for public health. But still, not all lead piping has been replaced by safer materials. Infrastructure is established for the sake of providing goods and services which are essential for all of us. Any interruption in the supply of essential services disrupts our daily routines. And if service disruptions are long-lasting on a large enough scale, they disrupt society and the economy. And it is therefore of the utmost importance that infrastructure is robust. Infrastructure robustness is not only created by the quality of materials and construction, but also by the network design. Compare, for example, a tree-structured network and a meshed network. As you see, in a meshed network, alternative routes may be available for the supply of infrastructure services if a specific link or node in the network fails. A tree structure topology is typical for drinking water supply networks, and these networks are typically dimensioned in such a way so as to ensure that the residence time of drinking water in the network does not exceed certain limits, and these limits are imposed to ensure the quality of drinking water. However, if one link in the network fails, all downstream connections of that particular link will also fail, and consumers will find their drinking water supply interrupted. In a meshed network topology, on the contrary, all consumers can still be supplied if one link fails. This type of topology is usually found in the electricity network, especially in the high voltage transmission network. Ring structures are applied here to ensure that the electricity supply is not interrupted if one link or component fails. And this design principle is known as the N-1 criterion, or so-called N-1 security. N-1 is an explicit criterion for transmission grid planning, ensuring that the grid can experience outage of a single transmission line, cable, transformer, or generator without causing losses in electricity supply. If such a failure occurs, the network operator must be able to contain the failure, and furthermore, the voltage must remain within the permitted limits, and the remaining network and components may not be overloaded. This means that the network is designed on purpose to be redundant. Although redundancy comes with substantial additional infrastructure cost, electricity provision is such a crucial service for society that the additional cost is justified. And in case of particularly sensitive network areas, for example where chemical plants or steel factories are connected, even stronger network security measures may be imposed, like N-2 security. In that case, two links or components may fail without causing a supply interruption. And this is meant to cope with situations in which a failure occurs in one component, while another network component is shut down for maintenance. Another feature of infrastructure is that both the network and the service it provides are highly standardized. This allows for interconnection of local, regional, and national networks, and it enables us to use the same user devices wherever we go. Unfortunately, not every country has adopted the same standards for sockets and plugs, so we still have to bring our adapter plugs when traveling. Due to the long lifespan of infrastructure and the high reliability of infrastructure services, most people in Western economies are most of the time hardly aware of infrastructure. Most infrastructure is invisible, buried underground, while visible infrastructure is more or less seen as part of the landscape. As we are used to a high reliability of service, we tend to take the availability of infrastructure services for granted, as if they were a fact of life. And thus, over time, most infrastructure has become deeply embedded into the spatial, economic, and social structure of our societies. But given the long lifespan of infrastructure, including energy infrastructure, it is nothing short of a miracle that the infrastructure designed in the past has been serving society so well for decades, during a time of drastic change from an industrial economy to modern post-industrial society. Over the lifespan of the infrastructure, societal needs and priorities have changed, new technologies have emerged, the spatial distribution of supply and demand has changed, use patterns have changed, and so forth. So, infrastructure systems are constantly being adapted. They are best seen as evolving systems. And this brings me to the core message of this first video on infrastructure planning. The long lifespan of infrastructure and the essential character of infrastructure services imply that infrastructure planning requires policymakers and engineering professionals alike to adopt a forward-looking approach long into the future. Infrastructure should not only be planned to meet the needs of today's population and economy, but it should also cater for the needs of society in the future. This brings a special responsibility for all professionals involved in infrastructure planning. We cannot predict the future, but we have to acknowledge the uncertainties regarding the future use and supply of infrastructure services. And we have to make a serious effort to plan new infrastructure for flexibility, adaptability, and robustness in view of these uncertainties. Thank you for watching.